We're excited to introduce our guest speaker this evening. His name is Paul Bergner. Paul Bergner has been practicing clinical nutrition with medical herbs and natural care since 1973. He has edited the Medical Herbalism Journal since 1989 and has also previously edited the Clinical Nutritional Update newsletter and the Naturopathic Physician magazine. He is the author of 7 recent books on medical herbs and clinical nutrition, including The Healing Power of Minerals and Trace Elements, published by Prima in 1997. He is director of the North American Institute of Medical Herbalism in Boulder, Colorado, which offers certification courses and clinical internships in medical herbalism and clinical nutrition. He also teaches nutrition at Naropa University in Boulder. Paul Bergner.
Thank you very much. I'm honored to be speaking before such an international crowd, and I'm very pleased to see people from so many parts of the world here. I don't need to explain what minerals are to an audience like this, but I will say the Earth is composed of minerals. The planet that we live on is composed of minerals, and our bodies are derived from that planet, from the materials of that planet. Our bodies are built out of mineral, among some other elements, but the minerals are essential to that. Those minerals from the earth make their way to our bodies through the food chain. The minerals are broken up from the earth, from the stones of the earth. They're dispersed in the soil. They're absorbed in plants, and then we eat the plants, or animals eat the plants, and we eat the animals. And the minerals are also dispersed in the sea. Animals that live in the sea eat sea plants. We eat the sea animals or the sea plants, and in that way that's the normal way we get minerals into our bodies, and we must have those minerals. There are approximately 77 minerals that are in the earth that are non-radioactive, and they are incorporated into our bodies. We've identified roles for at least 22 of those minerals. Recent nutritional science in the past 30 years has identified important roles in the human body, essential roles in the human body for a group of 16 trace elements, which are minerals that are required in a very small amount in the body. So, using this much as an introduction, I would like to talk about the role of the minerals. One of the major roles of the minerals in the body is structural. It maintains the structure of the body. And the most easy to understand mineral that does that is calcium, because calcium makes up the bones, and the bones allow us to stand and bear weight, and they protect our inner organs. But this is the structure of the body. It's made of minerals. And the roles for some of the minerals, we used the terms, they're regulators. They regulate processes in the body. For this purpose, I'd like to put my first overhead here. And we have a term here. The term is minerals act as rate-limiting cofactors. So we have a process in the body described here on the chart as A moving to B. And that moves at a certain speed, which is called the rate. A moves to B, or it moves in a certain volume. An amount of A is transformed into an amount of B at a certain rate. Well, here we have item C here is called a rate-limiting influence on that process. So if you have more C, then you get more B. Or as we have here, which is more likely the case in nutrition and mineral nutrition, if you have less C, you end up with less B. So the amount of C determines the amount of B that is produced from A, or the speed at which it happens. This is one simple model here. In the body, if C were the mineral magnesium, there would be more than 400 different processes that it limits. So magnesium is involved in more than 400 different enzyme reactions in the body. Zinc is also involved in more than 100. Combined, the two combined are probably more than 500 different transformational processes in the body. The rate at which they happen is determined by the amount of magnesium and the amount of zinc that's present in the body. An example of that, if A is glucose and B is energy, every cell in the body has the ability to make energy from glucose. And one of the factors that limits the amount of energy that can be produced from the sugar you eat is zinc. It's a chemical process called the Krebs cycle. If you have less zinc, you get less energy even though you're eating enough food. Another process of A to B would be the liver's function of detoxification. You have toxin circulating in your blood, that's A, and the liver transforms that into B, which is a harmless substance or a substance that can easily be excreted. And the rate at which that happens depends on magnesium. So if you have less magnesium, you have less detoxification activity in the liver. This is an all-important concept, and I don't want to be too abstract at the beginning, but this is important to understand the role of minerals, because many of the minerals and trace elements fall on this chart. They would be in the position of C, permitting or they're limiting the rate at which processes in the body function. So the next thing I would like to cover, we'll keep that there for a moment, is the problem of a deficiency disease. Most deficiency diseases in the body, if C becomes enough depleted, you end up with a disease in the body because you have an absence of B. But these deficiency diseases progress in a very well-ordered stage. It's the pathology, the pathological process of a nutrient deficiency. So we know in medical physiology, there's a process called homeostasis. Homeostasis means a steady state, or keeping the same state. In the body's blood and extracellular fluid, the fluid that bathes all the cells in the body and gives them their nutrients and their oxygen, the body has processes to keep that at a steady state. There's a narrow range of oxygen that's in the tissues. There's a certain narrow range of salt concentration, a certain narrow range of acidity, a narrow range that calcium is kept at a steady level in the blood, and so on. So the physiology, you'll see this on the first page of any physiology book, it talks about homeostasis, the body maintaining a steady state. If you imagine the body's state, the state of the blood and the extracellular fluid, as in the middle, how can it maintain a steady state of nutrients in that fluid? You either take them in from the diet, or they're taken out of the body's stores. So there are mechanisms in the body to store these minerals for a rainy day, where if you eat more than you need, it passes through the blood and the extracellular fluid, and then it's stored in the body. And this is like a savings account. And then during a time of day when you're not eating, between meals, or during a time in your life when there aren't enough nutrients, your body takes it out of the stores. One of the savings accounts in your body for calcium is your bones. The bones are not just structural organs, they're a savings depository for calcium. And if you're not eating enough calcium, the body will take the calcium out of the bones in order to keep blood levels up. Calcium is also stored other places in the body. In the body, the savings account in the body for magnesium is in the muscles. Much magnesium is stored in the muscles. If you don't eat enough magnesium, the blood will rob the tissues of its magnesium. This is not controversial. This is a well-understood basic physiological process. How that causes disease is these nutrients are in the tissues playing a role in those tissues, but they also have a functional role in the tissues. They aren't just sitting there waiting to be taken. They have a role there. The calcium in the bones supports the bones. The magnesium in the muscles prevents the muscles from becoming too spasmodic. They're sedative to the muscle. The magnesium is to muscle contraction. So what happens if you start robbing those stores out of the body's tissues? At a certain point, the body's function doesn't happen right, and we get what's called a functional disease. And if you hold that for one moment, if this progresses further, it actually changes the tissues in the body, and then you get an organic disease. So a functional disease, anxiety, depression, fatigue, immunodeficiency. You don't feel well. Things aren't functioning the way they should. Well, if this progresses on to osteoporosis, joint degeneration, gallstones, organ damage, then that's organic disease. The tissue has actually been changed. So if you understand that the progression goes from health to functional disease to organic disease, then we can understand the pathology of mineral malnutrition. Because as we become malnourished, first we have